electronics, we use certain devices. It's called power electronic devices. These power electronic devices, it's also called power electronic switching devices. You should know there is a new term I'm introducing here now. It's called switching. So why do we have this new term switching? Because almost all PE devices, so shortly we can call power electronics as a PE here. All PE devices are acting like a switch. So we should remember the switching characteristics. Generally, what the switch is doing in our home, we have switch right in our home. So we use this switch to turn on the light, to turn off the light, on and off. Or it can be any other load. It doesn't need to be the light bulb or whatever. So what is happening here, when switch is on, switch connects to conducting paths and make the circuit in a closed loop. For example, this is what happening in the switch. So you have here like this, 2 points. One is the phase, another one is neutral. So these down 2 points are connected to the electrical power supply. So that is coming from your fuse box in your home. So that is the 230 volt AC. It's a 50 hertz in Europe. In USA, it's a different rating. In USA, it's 110 volt, 60 hertz. They use a different standard. Okay, so this is what connected in the switch, one side. And the other side of the switch is connected to the load. Maybe here I have the bulb. So when you turn on this, what is happening? You are connecting this point to this point. So now I turn on this. Now the switch is off, right? So when the switch is off, so now this is not connected. So when the switch is off, switch disconnects the contacting path. This is the contacting path in a circuit. So it acts as an open circuit. So in the open circuit, there is no current flow. There is no current because the circuit is open. It's not connected. So the current is not flowing. So the bulb is off. But if the switch is on, then these 2 points are connected. Then there will be a current flow. Then the bulb will be on. So the same principle for any application. It can be your electric heater, or it can be your any other application. So this is the principle of the switch. When the switch is off, the switch disconnects the conducting path in a circuit. It acts as an open circuit because it's off and there is no current flow. So it deals with, so ideal switch has zero current and it can withstand infinite voltage drop. It means when the switch is off, there is no current flow. Current is zero. I is equal to 0. This is for the off. Open circuit. OC, open circuit. Off state, I is 0. The voltage drop can be any much. So even though here the voltage is whatever the voltage, the switch will not break. So it can withstand the voltage to infinity. Okay, so this is for the off state. So on state, what is happening? On state means it's a short circuit, SC. So this is OC, open circuit, and this is the short circuit, SC. So during the short circuit or on state, what is happening here? So there is a current flow. Yes, the current is flowing here like this. And ideal switch can withstand infinite current. So whatever the current, even though it's a 1 ampere or 10 ampere, it can withstand. Of course, up to your fuse capacity, it can withstand. And it can also, it will have zero voltage drop. So this is the difference. So here you should know when the switch is on, the current is flowing, which is infinite. I is equal to infinite and voltage drop is equal to 0. But when the switch is off, current is 0, voltage drop can be infinite. Okay, so this is the basic operation of the switch. So at home, in our home, in everyone, we have on off switch for the lights. So now you know what is switching. So we can apply this same theory, switching theory, for high voltage, high current, and high frequency circuits. Okay, so now we know what is happening. So when we use PE devices as a switch to handle such high power, high voltage. High power means what? So it has high voltage and high current. So that is high power. So we know the formula, right? P equal to VI. So for high power means, of course, definitely it's directly proportional. So high voltage and high current. So that is why it's called power electronics switching devices. Okay, so we are using these power electronic devices as a switch between the source and load. And these power electronic devices will act like a switch. So it means it can open for some time, it can on sometime, it can off sometime, it can be off. See here, it can open and close instantly, very fast. So thus no switching losses and at a high rate. So let me explain in other way. So maybe for example, now I have plus 10 volt DC as the source. So my load needs only 5 volt DC. So what I am going to do is I have the source that is the plus 10 volt. So I use the power electronic device. I told you power electronic devices are acting like a switch. So it means open and close, open and close. And here I have the load. The load needs only plus 5 volt. So I am giving this plus 10 volt DC to this power electronic device. Let us say this power electronic device may be an SCR. SCR. We will see the devices, different devices later. SCR means silicon controlled rectifier. Okay, so I am giving this 10 volt DC to this one. So I turn on the switch and for maybe 1 microsecond, I turn off the switch 1 microsecond. Or I can change the duty cycle. So the DC voltage, if I have the, maybe I turn on for, let's say 1 microsecond, and then I turn off 1 microsecond. This is the 0 level, reference level. Turn off, and then I turn on again 1 microsecond, it's on, and then I turn off again 1 microsecond. And I turn on again 1 microsecond and turn off again. So it means I turn on and off this SCR. So what is happening here is reducing this 10 volt into certain another level. So now I just make some kind of smoothing filter. This smoothing filter will make this voltage as a smooth, and then instead of 5 volt here, maybe this is the 0 level, the reference I have 0 volt, and this is a 10 volt here in this level. So here is the 0 is the reference, this x-axis, this y-axis, and now instead of plus 10 volt, I am getting 5 volt, plus 5 volt DC. So this is how we are using this power electronic devices as a switch. So we can just change the duty cycle. We can change the on time and we can change the off time, on period and off period. So in any pulse, yeah, here we have already. So any pulse we have here on state, and this is off state. This is on state and this is off state. So if you just make like this, so this is how the power electronic devices are working and controlling the supply voltage and changing to whatever the level you want. So here I just only changed the voltage level from 10 volt to 5 volt. I can also change the frequency. So this switching characteristic of power electronic devices are very important. So this is a very basic, you should understand. This is what we are going to use all the way in any kind of PE device. Mostly we are using this switching characteristic, on and off, on and off. So by making this on and off, so we are controlling and we are reducing the voltage or frequency or current level. And to turn on and off, how can you control this the PE device? ACR, how can you control? For example, it has 3 terminals, maybe it has a gate. So I am giving gate voltage. By giving the gate voltage, I am controlling this ACR. Okay, now let's move on further. But in practical switches, we have the conduction loss, P equal to VI, and we also have the switching loss by opening and closing.
I have just a question.
Yeah.
But I was wondering about the switching technique, okay?
Yeah.
You know, when you're switching it on and off, I was wondering, are you just cutting the period off instead of the amplitude of the voltage?
Yes, certain. You are making off period, right? During the off period, there is no amplitude at all. And you are having the on period, and then you are making another off period. And finally, you are going to make the average at the output. I told you there will be a smoothing filter. So smoothing filter will make the average of these things. So when you make the average, then it will be reduced automatically, the magnitude.
Okay.
Do you understand the concept? So you are instead of continuously giving 10 volt, you are just cutting off some period and then you are giving again and then cutting off again. So when you make the average, definitely it will be reduced than the original value.
Okay.
Yeah.